The number of exoplanets continues to increase, and our technology with telescopes and radio telescopes is becoming more and more advanced. We are discovering unusual signals from the cosmos, testimonies from people who tell us that they are already among us. And almost every week a discovery about strange signals in stars is announced. And yet, the big question persists. Why, despite so many stories, clues and discoveries of elements compatible with life, have we still not had clear contact with an extraterrestrial civilization? What is actually happening is much more intriguing than we could imagine. Today we will unravel a shocking truth, backed by scientific studies. We will begin a journey that will challenge your deepest beliefs. What you will discover not only reveals the deception that has clouded our vision, but also connects us to a surprising network that links extraterrestrial life with our own existence. This is a mystery that will change your perspective on the universe and your place in it. All or nothing. Are we alone in the universe, or are there other intelligent beings out there? Now, two astrobiology experts, David Kipping and Geraint Lewis, have approached this enigma from a new perspective, using a method called the James experiment. They have proposed that the answer could be simpler than we think. Either intelligent life is common in our galaxy, or it is incredibly rare. David Kipping is a professor of astronomy at Columbia University and a Carl Sagan Fellow at Harvard College Observatory. Geraint Lewis is a professor of astrophysics at the Sydney Institute of Astronomy. Through their research that challenges the traditional stances of SETI optimists and pessimists, they suggest that the existence of intelligent life could be an all-or-nothing matter. According to Arthur Clarke, this could be as fascinating as it is terrifying. It could be that we are on the cusp of discovering something great, or we are simply alone in the darkness of the cosmos. In 1961, astronomer Frank Drake presented a formula that would change the way we think about life in the universe. At the Green Bank Observatory, Drake proposed the equation that bears his name, designed to help estimate the number of advanced civilizations capable of communication in our galaxy. The Drake equation, although mathematical, it is actually a tool to open dialogue about the search for extraterrestrial life. The formula uses several factors to calculate the number of active civilizations in the Milky Way. These factors include the rate of star formation, the percentage of stars with planets, and the likelihood that these planets will develop life and intelligent life capable of communication. However, the equation is not intended to provide a definitive answer, but rather to encourage discussion and analysis. Over time, the equation has been criticized and misinterpreted. Since many of the values are uncertain, the use of the equation can put speculation on solid ground. Despite the criticism, the Drake equation remains a valuable starting point for exploring the possibilities of life in the cosmos. The James experiment. Now we come to something very curious. The James experiment. Developed by Edwin James, this experiment is particularly useful in situations where you don't have much prior information. In such a case, very high or very low extreme values are usually more likely, such as 0 or 1. Imagine you have a flask with an unknown chemical called X, and a series of beakers filled with water. The experiment consists of trying to dissolve this chemical X in each of the beakers and observing how many of them actually dissolve the chemical. The possible results can only be two: either the chemical X dissolves in almost all of the beakers, or the chemical does not dissolve in almost any of the beakers. What James argues is that before doing the experiment, it would be very strange to expect the chemical to dissolve in, say, exactly half of the beakers, or in a number close to half. It is much more likely that it will dissolve in almost all of the beakers, or in almost none of them. How can this be applied to intelligent civilizations in the galaxy? Very simple. We know that our universe has very tight variables for it to exist and for life to be possible, so life can only arise when certain conditions are met with a very narrow range of values. Imagine that the glasses filled with water represent planets with habitable conditions where life could arise. The unknown chemical represents the possibility of life appearing on those planets. If it dissolves in water, it means that as long as a planet has the ideal conditions, life will arise. If it does not dissolve, then life will not appear on most of those planets, or perhaps on none at all. This analogy helps us understand that without enough information, the results can be extreme. Either life is very common and arises anywhere where conditions are favorable, or it is extremely rare and hardly urgent, even on planets with good conditions. So if life is common, by pure statistics, advanced civilizations should arise on many planets where they have the ideal conditions. The universe should be full of advanced civilizations, building megastructures, emitting radio signals and leaving technological traces everywhere. If this were true, we would have already detected some of these signals. This is the heart of the famous Fermi Paradox. If there are so many possible extraterrestrial civilizations, why haven't we found any evidence? Galactic colonization and expansion are usually rapid on cosmic time scales, just a few million years. It's almost like a blink of an eye. It happens when there is an explosion of life. It is almost improbable to live in such moments of galactic history. On our planet, the time scale of intelligent life also lasted a cosmic blink of an eye. Cosmic habitability. Instead of getting complicated with the multiple factors of the Drake equation, the most important thing is the birth and death rate of civilizations. Any living being, species or civilization has a finite lifespan and also a narrow window where they can emerge, and there will be a moment in our galaxy and the universe where there will be an explosion of life. The universe was formed approximately 13.8 billion years ago with the Big Bang. In the first few minutes, the lightest elements were formed: hydrogen, helium, and traces of lithium. These elements are not sufficient for life as we know it. For life to emerge, heavy elements such as carbon, oxygen, nitrogen, iron, and others need to exist. And that can only happen in second and third generation stars. We are now in the prime time where life can develop and lead to intelligent life. The universe is old enough that the elements necessary for life are widely available and have been formed on many habitable zone planets. 4.5 billion years ago, when the Earth was formed, the probability of intelligent life existing in the universe was lower than today. Although the elements necessary for life were already present, the universe was still in a phase of development and stabilization that made the conditions for life, especially intelligent life, less common compared to today. Then we come to a disturbing conclusion. If we do not see intelligent life in the galaxy or signs of other civilizations, it means that most of the life in the universe is evolving, and evidently we are the first to appear, and we are alone. We are rare. The Jane's experiment, together with the Fermi Paradox, tells us that extraterrestrial civilizations are very rare, at least in our galaxy, so we should look in other galaxies. David Keeping believes that our galaxy is very quiet and that we are the first. If intelligent life were common, the galaxy would be conquered by other civilizations, and we would not have been able to even be born, since the habitable space would have been devoured by others. There must be galaxies where life emerges and is crowded. The same thing happens on our planet. There are species that become extinct and others will not be able to evolve because of our activities. We have been allowed to evolve, simply because we are the first, or we are alone. This approach is intriguing. But there is another equally striking one that says a lot about us. An exponential expansion is impossible. From my point of view, an expanding technology that consumes resources at an uncontrolled rate could theoretically exhaust the available resources in a galaxy. An uncontrolled technological expansion that exhausts the resources of a galaxy would not be sustainable in the long term. A truly advanced civilization would probably need to find a balance between expansion and sustainability to avoid a collapse. This could involve the development of extremely efficient technologies, the use of renewable energy on a galactic scale, and a deep understanding of the natural and physical limits of its environment would not need to expand in an uncontrolled manner. Without sustainability, any civilization, no matter how advanced, would face the same fundamental challenges of resource depletion and collapse that we face on Earth, only on a much larger scale. We cannot extend our behavior to the rest of the universe, no matter our desires, our inclinations and passions. The universe puts great filters on us for survival. We manage our planet very poorly, and our political and economic systems would not work on a galactic scale. That is why human beings are destined to self-destruction if they continue down this path. I look at the Earth with sadness. We are still like tribes, hidden in cement blocks. separated by imaginary borders, consuming all the resources without control, facing each other in a constant war, where most of the nations are in truce waiting patiently with their armies and nuclear weapons for any opportunity to intervene. Undetectable efficient energy. An efficient civilization cannot maintain an infinite rate of energy growth. The Kardashev scale is based on the potential of a civilization based on energy consumption and the use of the environment, but this cannot work for very advanced civilizations. There will come a time when the technology of intelligent beings is so efficient that they are difficult to detect, and that is why we do not see them. We are already seeing this in many systems that we use. The clearest example is fiber optics compared to radio communications. Fiber optics allows the transmission of large amounts of data with less energy loss compared to radio antennas. An advanced civilization could use highly targeted and efficient communication methods that do not waste energy in space, making them difficult to detect at long distances. Incandescent light bulbs convert a large part of the energy into heat, while LED lights are much more efficient. Imagine a civilization that has optimized all its technology to the efficiency level of LED lights, reducing its total energy consumption without sacrificing functionality. It is possible that an advanced civilization has also developed cloaking technologies or active stealth methods that allow them to avoid detection. This could include manipulating light, radiation, or even gravity to hide. Although we cannot say for certain that an advanced civilization would be completely invisible to us, they could be extremely difficult to detect with our current tools. Quantum communication. We use radio frequencies like SETI to listen to other signals in the universe. But quantum communication theory suggests that this technology would be ideal for interstellar communication, as it uses less energy and is more effective. If we follow the rule of sustainable development on a cosmic scale, it is possible that other civilizations use more effective methods than radio, but it would require a whole quantum network of kilometers of infrastructure to avoid interference with the cosmic microwave background. And therefore, we need to develop these instruments before we can receive signals from other civilizations. Personal conclusion. According to the study of experts, and my personal conclusion is that we are alone or a few civilizations are engaged in sustainable and silent exploration. Dyson spheres could be totally ineffective, since they would emit a large amount of energy, and that would be incompatible with the development of an advanced civilization. I believe that microbial life is abundant, but extraterrestrial civilizations are rare in our galaxy, although in the future they will be more numerous, and this is because the universe is at a time with a lot of heavy elements. Despite the numerous reports of UFOs, extraordinary claims, alleged contactees, and strange signals, there is no evidence of any kind, and most reports and stories are jokes and hallucinations. No one can deny that they have deceived us all and continue to do so by confusing the public, where they want us to believe that there is a global conspiracy, and that every week our planet seems to be the playground and meeting point for other civilizations. This is the truth. We have not yet confirmed extraterrestrial intelligent life. We have only found noble gases, carbon compounds, and fluctuations in stars and fast radio signals. Nothing that cannot be explained by natural methods. We continue to advance in our knowledge, and until we detect clear signals, we must take the data with caution. In our cosmic solitude, we imagine beings that, like us, might desire company or perhaps seek to warn us about unknown dangers. But is this a projection of our own desires and fears? Are we deep down searching the cosmos for a reflection of ourselves? Science guides us through the facts and is the best tool we have. It does not promise immediate certainties, nor incredible stories, but the truth to our questions. Hush.